Welcome, everyone. Ready to dive deep into the core of JavaScript. We're going to untangle how it juggles so many tasks without becoming a tangled mess.
It's all thanks to the event loop,
The event loop.
a system that makes sure JavaScript can fetch data, respond to your clicks, and keep things moving smoothly all at the same time.
I've always been curious about that, how JavaScript can do so much when it's single-threaded.
It's like that waiter who can only serve one table at a time but somehow keeps the entire restaurant running.
Exactly. So how does it keep track of everything? Is there like a giant to-do list somewhere?
You could say that. It's called the call stack.
A call stack.
Imagine a stack of plates.
Okay.
Each task or function gets added to the top, like a new plate, and JavaScript works its way down, executing each one.
So it's like the last order in is the first one out?
Exactly. LIFO, they call it. Last in, first out.
Makes sense. But what if a task takes ages, like fetching something from a server? Does everything else just have to wait?
That's where things get really interesting. JavaScript doesn't just sit there and wait.
It doesn't?
Nope. It uses these things called web APIs. They work outside of the main thread, like sending an order to the kitchen.
So JavaScript can keep taking new orders while the chefs are busy cooking.
Exactly. That's how it stays responsive.
Okay, but how does it know when those kitchen orders are ready?
That's the callback queue's job.
The callback queue, another queue.
Think of it as the signal from the kitchen, letting the waiter know an order is ready.
I see. So the callback queue is like a waiting area for completed tasks.
You got it, and the event loop is constantly checking this queue.
We're always checking.
If the call stack is empty, meaning JavaScript is free, it grabs the next task from the callback queue.
So even though it's single-threaded, JavaScript uses this system of delegation and queues to multitask like a pro.
Now there's one more piece to this puzzle.
There's more?
It's called the Microtasks Queue.
Microtask queue, that sounds important.
It is. It's like a VIP line, mainly for promises.
Ah, promises. Those all get back to you. Guarantees in code.
Precisely. They get handled before anything in the regular callback queue, like the waiter getting a VIP table ready in advance.
So the microtask queue gets priority.
Exactly. It's like ensuring that crucial tasks, often related to the user interface, are handled ASAP.
So even though JavaScript works on one thread, it uses these clever systems to manage everything.
It delegates tasks, uses queues, and prioritizes them to keep things running smoothly.
This is fascinating. It's like seeing the behind-the-scenes magic of how JavaScript actually works. But how do we actually see this in code?
Let's take a look at a simple example.
Okay, I'm ready to see this in action.
Imagine a function called greet. It just logs a message to the console.
Like our waiter taking an order for, say, a glass of water?
Exactly. We call the function, it goes on the call stack, gets executed, and then it's done off the stack.
Simple enough.
Now let's say we use setTimeout. That's a web API function.
Okay.
It lets us schedule a task, like another greeting message, to happen after, let's say, 2 seconds.
So like an order that needs some prep time in the kitchen?
Exactly. setTimeout doesn't stop everything else. It just schedules the task and moves on.
So JavaScript is free to do other things while that 2-second timer is running.
And once the timer's up, the callback function goes into the callback queue.
Waiting patiently for its turn.
When the call stack is empty, the event loop picks it up and puts it on the call stack to be executed.
Okay, that's making a lot more sense. But what about promises? How do they fit into all of this?
Imagine a promise that resolves after 1 second, logging another message when it does.
Okay, so it's like getting a notification that a table will be ready in a second.
Precisely. The promise starts in a pending state, then after 1 second, it's fulfilled.
It's all.
And the function that's supposed to run when it's fulfilled goes straight to the microtask queue.
And because the microtask queue is like the VIP line, it gets handled first, right?
Exactly. Even before that setTimeout task we set up earlier.
So even though it was scheduled later, the promise gets priority.
Exactly. It ensures those important tasks, like updating the user interface, happen quickly.
This system makes so much sense. It's like looking under the hood of a well-run restaurant.
Now imagine all these things happening at the same time. The simple greet function, the setTimeout, and the promise.
So like a mix of quick orders, things that need prep time, and a table reservation.
The event loop handles it all. Let's break it down step by step.
Let's do it.
First, the greet function, it's synchronous. So it goes straight to the call stack, gets executed, and it's done.
Just like that quick drink order.
Then the setTimeout is scheduled, and the promise starts its journey.
The waiter sends the order to the kitchen and gets that reservation notification.
And JavaScript doesn't wait for either of them to finish. It keeps going if there's more to do.
Like a waiter attending to other tables while things are being prepared.
After 1 second, the promise resolves, and its callback goes to the Microtasks Queue.
The table is ready, and the waiter gets the notification.
The event loop sees the Microtasks Queue isn't empty, so it takes that callback and puts it on the call stack to be executed.
So the waiter prioritizes the table that's ready, even though the other order was placed first.
Exactly. The promise callback runs, logging its message, and then after another second, the set timeout is done.
The food is ready, the kitchen sends the signal.
The event loop sees the call stack is empty again, grabs the set timeout callback from the callback queue, and puts it on the call stack.
And finally, the waiter can serve that dish.
The set timeout callback runs, logging its message, and just like that, all 3 tasks are done in the right order thanks to the event loop.
Wow, this really breaks it down. It's like seeing the magic behind the scenes.
The event loop is the maestro, keeping everything in sync.
But I bet things can get even more complex in real-world applications, right?
They can, and that's when a deep understanding of this system becomes crucial.
Well, I'm definitely ready to dive deeper, but for now, let's let all this sink in for a bit. We'll be back soon to continue our exploration of the JavaScript event loop. And we're back, exploring the depths of JavaScript's event loop.
It's what keeps our apps running smoothly. No more spinning wheels of doom.
Exactly, no more frozen websites. But can even the event loop get overloaded? Can we accidentally mess things up in our code?
Definitely. Even with this system, we need to be careful not to block it.
So it's not foolproof. We still need to be mindful of how our code works with the event loop.
Exactly. One common mistake is writing code that takes too long and hogs the main thread.
So it's like our waiter getting stuck chatting with one customer and ignoring everyone else?
Precisely. Even if we're using asynchronous operations elsewhere, one long task can bring everything to a standstill.
It's a bottleneck, like that one really slow step in a recipe.
Imagine a loop going through a huge list, doing complex calculations on each item.
That sounds intense.
It would completely occupy the call stack. Nothing else could happen until it's finished.
Like that waiter writing down one super detailed order holding up the entire restaurant.
Exactly. That's how you get slow, unresponsive applications. So how do we avoid that?
Yeah, how do we keep the event loop happy and our code running smoothly?
We need to break down those big tasks into smaller chunks and use asynchronous operations.
Okay, so instead of processing everything at once, we split it up.
We can use set timeout or promises to schedule those smaller tasks.
So it's like taking orders from a few tables, sending them to the kitchen, and then moving on to the next group.
Precisely. We free up the main thread while those longer operations are happening in the background.
It's all about keeping the waiter moving, taking orders, serving drinks, making sure everything flows.
And promises play a crucial role in this dance.
We touched on them earlier, but how do we use them effectively to avoid blocking?
They provide a structured way to manage these asynchronous operations. And remember the Microtasks Queue.
The VIP line.
Promises have a special spot there. They're like those IOU notes the waiter gives out when a dish will take a while.
They guarantee a result later on, right?
Exactly. And they let us chain together multiple operations, making the code cleaner and more efficient.
So instead of a bunch of nested callbacks, which can get really messy, promises keep things organized.
Imagine numbered tickets instead of the waiter trying to remember every single detail.
That makes sense. It's like a system for keeping everything straight.
And because they use the Microtasks Queue, those promise-related tasks get done quickly.
Even before things in the regular callback queue.
Exactly. Important tasks, like updating what the user sees, happen right away.
So promises aren't just good for readability, they help with performance and responsiveness too.
It's a win-win. And there's another tool that works really well with promises.
Oh, tell me more.
It's called Async, and it lets us write asynchronous code that looks and feels synchronous.
Wait, asynchronous code that looks synchronous? How is that even possible?
It's like syntactic sugar, making the code nicer to read and write without changing how it actually works.
Okay, I'm intrigued.
With Async, we can use the await keyword to pause execution until a promise is resolved.
So it's like politely asking a customer to wait a moment while you fetch something, but without stopping everything else.
Exactly. It makes the code flow more naturally, easier to understand.
That sounds incredibly useful for complex operations. But before we get too advanced, are there any other fundamental principles we should keep in mind with asynchronous JavaScript?
Remember that the order these operations finish in isn't always guaranteed.
It's not.
Just because you send an API request first doesn't mean it'll be the first one back.
So it's like two dishes ordered at the same time. The second one might be ready first.
Exactly. Network speed, task complexity, lots of things can affect timing. This non-deterministic nature is something we always need to consider.
So we can't assume anything about the order.
We need to handle different scenarios, avoid those race conditions.
Race conditions, those sound dangerous.
They happen when the outcome depends on which task finishes first, like two chefs grabbing for the same dish.
Oh, I can picture that ending badly. So how do we prevent these race conditions and make sure our code works properly?
We have tools for that. Promise chaining with then is one way to ensure things happen in the right order.
Okay, so even if the dishes are ready out of order, the waiter still serves them in the right sequence.
Precisely. And promise.all is another useful one. It lets us wait for multiple promises to resolve before moving on.
So it's like waiting for all the dishes for a table to be ready before serving them.
These techniques give us more control over the flow, helping us avoid unpredictable outcomes.
It's like being a conductor, making sure the whole orchestra plays in harmony.
Exactly. And one last thing, don't forget about error handling.
Right, things can go wrong.
Asynchronous operations can fail, network issues, bad data. It happens. We need solid ways to handle those errors gracefully.
Like having a backup plan in case a dish gets dropped or an ingredient is missing. You don't want the whole restaurant to shut down.
Exactly. By handling errors well, we make our applications more robust and reliable.
This has been an incredible deep dive so far.
We've explored the inner workings of the event loop, seen how it keeps JavaScript running smoothly.
And we've uncovered practical techniques for writing better asynchronous code.
It's a fundamental concept that makes JavaScript so powerful and flexible.
I'm feeling much more confident in my understanding now, but I'm sure there's still more to learn.
There's always more to discover in the world of asynchronous JavaScript.
I'm ready for the challenge. But for now, let's take a short break to absorb all this amazing information. We'll be back soon for the final part of our deep dive into the JavaScript event loop. And we're back, diving deeper than ever into the mysteries of the JavaScript event loop.
We've journeyed through the call stack, explored the web API wilderness, and even conquered the queues.
The Callback Queue and the Microtasks Queue, those are quite the adventure.
But it's all about keeping JavaScript running smoothly, even with all those asynchronous tasks happening.
It's like a well-choreographed dance, everything in sync.
Before we wrap up this deep dive, any last words of wisdom for our listeners who want to become asynchronous JavaScript masters?
Yeah, any parting tips?
Mastering asynchronous JavaScript, it's a journey, not a destination.
I like that.
There's always something new to learn, always another challenge to conquer.
It's all about continuous learning, pushing the boundaries.
Exactly. And don't be afraid to explore the tools and libraries out there.
Oh, yeah, those can be lifesavers.
Libraries like Async.js, they offer a whole toolbox for working with asynchronous patterns.
Like having a specialized sous chef to handle those tricky dishes.
They can save you time, headaches, and they often incorporate best practices for those common asynchronous scenarios.
That's super helpful. Any other specific things we should watch out for?
When you're working with multiple asynchronous operations that depend on each other, that's where things can get tricky.
Oh, yeah, like a chain reaction.
You need to manage those dependencies carefully, avoid those race conditions we talked about.
Right. Those can lead to some unpredictable results.
Techniques like promise chaining and promise.all, they can help you keep everything in order.
Like making sure those dishes are served in the right sequence, even if they're ready out of order.
Precisely. And error handling. Never forget error handling.
Right. Things can go wrong, especially with asynchronous operations.
Network issues, bad data, you need to be prepared for anything.
It's like having a backup plan in case a dish gets dropped or an ingredient goes missing.
Exactly. You don't want one small issue to crash the whole system.
Solid error handling makes our applications much more reliable.
We've covered a lot of ground today, from the inner workings of the event loop to practical tips for writing better code.
This has been an incredible journey into the heart of JavaScript.
The event loop, it's the unsung hero that makes it all possible.
It's what allows JavaScript to handle so much, to stay responsive and efficient.
Keep exploring, keep experimenting, and keep pushing the boundaries of what you can create with this amazing